There's a moment when you look up at the night sky that feels almost timeless, like you're gazing into the same infinite canvas that countless generations before you have tried to understand. What if I told you that every star, every swirling nebula, and every distant galaxy has been part of an ongoing story, one that humans have been mapping for thousands of years? This is the world of celestial cartography, the art and science of charting the heavens. It's not just about plotting points in the sky, it's about unraveling the mysteries of the cosmos, one map at a time. From the earliest star charts etched into clay tablets to the breathtaking 3D models created by today's most advanced telescopes, celestial cartography has been our way of making sense of the universe. And here's the thing: every map tells a story of discovery, of curiosity, and of humanity's relentless drive to explore the unknown. So, let's take a journey together through the stars and beyond, and uncover how we've mapped the cosmos and why it matters more than you might think. Long before the invention of telescopes or the launch of satellites, humans were already mapping the heavens. Ancient civilizations like the Babylonians, Greeks, and Chinese gazed at the night sky not just in awe, but with purpose. For them, the stars were more than distant lights. They were guides, markers of time, and even characters in the stories that shaped their cultures. Imagine standing under a clear, unpolluted sky thousands of years ago, tracing patterns in the stars that would one day become the constellations we know today: Orion the Hunter, Ursa Major the Great Bear, and so many others. These patterns weren't just random groupings. They were the earliest star maps, tools that helped societies navigate the seas, predict the seasons for farming, and connect their myths to the cosmos. The Babylonians, for example, were meticulous record keepers. They tracked the movements of planets and stars, creating some of the first known celestial charts. These weren't just scientific documents, they were tied to their belief systems, used to predict events they believed were influenced by the gods. Meanwhile, the Greeks took these observations and added their own stories, weaving mythology into the stars. Figures like Perseus, Hercules, and Andromeda weren't just heroes of legend, they became immortalized in the night sky. And in China, astronomers mapped the heavens with incredible precision, using their star charts to keep time and even predict eclipses. What's fascinating is how these early maps blended art and science. They weren't just functional, they were beautiful, often adorned with intricate illustrations that reflected the cultures that created them. This mix of observation and imagination laid the groundwork for everything that followed. These ancient astronomers didn't have the tools we have today, but they had curiosity, creativity, and a deep desire to understand their place in the universe. Their star maps were the first steps in a journey that would eventually lead to the detailed, three-dimensional models of the cosmos we have now. And while their methods were different, their goal was the same as ours: to make sense of the vast, mysterious expanse above us. Their legacy is a reminder that celestial cartography isn't just about science, it's about storytelling, exploration, and the timeless human need to find meaning in the stars. When you look up at the night sky, it's not just stars you're seeing, it's a tapestry of stories. For ancient cultures, the heavens were alive with myth and meaning. The stars weren't just points of light, they were gods, heroes, and creatures, each with a tale that helped explain the mysteries of the universe. Mythology and astronomy were inseparable, with every constellation serving as a chapter in a grand cosmic narrative. Take the Greek myth of Perseus and Andromeda, for instance. Their story, filled with bravery, love, and divine intervention, is etched into the stars, a celestial reminder of how deeply intertwined our understanding of the cosmos is with the stories we tell. These myths weren't just entertainment, they were tools. Imagine living in a world without written maps or GPS. How would you navigate the vast, open seas or keep track of the changing seasons? The stars, anchored by these mythological figures, became a reliable guide. Orion, with his unmistakable belt, pointed the way for sailors. Ursa Major, the Great Bear, helped farmers predict the arrival of spring. By assigning stories to the stars, ancient cultures made the night sky unforgettable. The constellations became mnemonic devices, helping people remember the positions and movements of celestial bodies. It's a brilliant example of how storytelling and science worked hand in hand to make the cosmos accessible. But the influence of mythology goes beyond practicality. These stories gave the stars a sense of purpose and personality. They transformed the night sky from a cold, distant expanse into something deeply human, filled with drama and emotion. The Egyptians saw the stars as gods sailing across the heavens in celestial boats. The Norse believed the Milky Way was the path to Valhalla, the warrior's afterlife. And the indigenous peoples of Australia wove the stars into their dreamtime stories, connecting the land, the sky, and their ancestors. These narratives weren't just about the stars, they were about people, their values, fears, and aspirations. Even today, mythology continues to shape how we see the stars. The names of constellations, planets, and even spacecraft often draw from ancient myths. NASA Artemis program, for example, is named after the Greek goddess of the moon, a nod to the program's goal of returning humans to the lunar surface. It's a reminder that our exploration of space is still deeply rooted in the stories that first inspired us to look up. Mythology gave the stars meaning, and in doing so, it gave us a way to connect with the cosmos on a personal level. It's not just about mapping the heavens, it's about understanding our place within them, a journey that began with stories and continues to this day. The Middle Ages might conjure images of castles, knights, and chivalry, but it was also a time when the night sky became a canvas for both science and art. While Europe was often characterized by its feudal systems and religious fervor, the Islamic world was experiencing a golden age of learning, and together, these two spheres became the keepers of celestial knowledge. Medieval star maps were more than just tools for navigation or study, they were masterpieces that blended precision with beauty, capturing the heavens in ways that still inspire awe today. In the Islamic world, astronomers like al-Sufi took the ancient traditions of star mapping and elevated them to new heights. His work, the Book of Fixed Stars, wasn't just a catalog of celestial objects. It was a meticulously detailed guide that combined centuries of Greek, Persian, and Indian astronomical knowledge with his own observations. Al-Sufi didn't just list stars, he illustrated them, creating vivid depictions of constellations that were both scientifically accurate and artistically breathtaking. His maps weren't just for scholars, they were works of art that brought the heavens to life, making the stars accessible to anyone who held a copy. Meanwhile, in Europe, monasteries became the unlikely hubs of celestial cartography. Monks, often the most educated members of society, took on the task of preserving and advancing astronomical knowledge. They produced illuminated manuscripts, handwritten books adorned with gold leaf, vibrant colors, and intricate designs that depicted the heavens in stunning detail. These weren't just scientific documents, they were expressions of faith and wonder. For many monks, mapping the stars was a way to understand God's creation, a reminder of the divine order that governed the universe. The constellations they illustrated weren't just patterns of light, they were symbols of spiritual truths woven into the fabric of their beliefs. What's remarkable about these medieval star maps is how they bridge the gap between ancient and modern cartography. They preserve the knowledge of the Greeks, Babylonians, and others while adding new layers of observation and artistry. Take, for example, the Zodiac Man, a common motif in medieval manuscripts. This figure, superimposed with the constellations of the zodiac, wasn't just a decorative element, it reflected the belief that the stars influenced human health and destiny. It was a blend of science, art, and spirituality, a reminder that the heavens were deeply connected to life on Earth, but these maps weren't static relics of the past. They laid the groundwork for the Renaissance, a time when the boundaries of science and art would expand even further. The meticulous observations of Islamic astronomers and the artistic innovations of European monks ensured that the knowledge of the stars wasn't lost to time. Instead, it was passed down, refined, and built upon, creating a foundation for the groundbreaking discoveries that would come later. Medieval star maps remind us that science and art aren't opposites, they're two sides of the same coin, each enriching the other. They show us that understanding the cosmos isn't just about data and measurements. It's about wonder, creativity, and the timeless human desire to make sense of the universe. The Renaissance wasn't just a rebirth of art and culture. It was a revolution in how we saw the universe itself. For centuries, the heavens had been mapped through the lens of myth, tradition, and the limited tools of the past. But as the Renaissance dawned, a new wave of thinkers emerged, armed with curiosity and a willingness to question everything. Among them were figures like Copernicus, Galileo, and Kepler, whose work didn't just refine celestial cartography, it completely redefined it. This was the era when the telescope, a humble instrument of glass and metal, became a window to the stars, revealing details no one had ever imagined. And with every observation, the old ideas about the cosmos began to crumble, making way for a new understanding of the universe. At the heart of this transformation was Nicolaus Copernicus, a Polish astronomer who dared to challenge the geocentric model, the belief that Earth sat at the center of the universe. In his groundbreaking work on the revolutions of the heavenly spheres, Copernicus proposed a radical idea: the Sun, not Earth, was the center of the solar system. This heliocentric model was a seismic shift in celestial cartography. It didn't just change how we mapped the stars, it changed how we saw our place in the cosmos. Suddenly, Earth was no longer the focal point of creation, but a small planet orbiting a much larger star. Copernicus's ideas were controversial, even heretical, but they sparked a wave of curiosity that would ripple through the scientific community for generations. Then came Galileo Galilei, the Italian polymath whose name is now synonymous with the telescope. Galileo didn't invent the telescope, but he perfected it, turning it into a tool that could reveal the hidden wonders of the night sky. Through his lens, he saw mountains on the moon, the phases of Venus, and the 4 largest moons of Jupiter, discoveries that shattered the notion of a perfect, unchanging heavens. Galileo's observations provided concrete evidence for Copernicus's heliocentric model, but they also did something more profound. They showed that the universe was far more complex and dynamic than anyone had imagined. His detailed sketches of the moon and his meticulous records of planetary motion became some of the first modern star maps, blending art and science in a way that captured the imagination of his contemporaries. But it was Johannes Kepler who took these observations and turned them into laws. Kepler, a German mathematician and astronomer, studied the motion of planets with a precision that had never been seen before. His 3 laws of planetary motion described how planets orbit the sun in elliptical paths, not perfect circles as previously thought. These laws didn't just explain the movements of celestial bodies, they provided a mathematical framework that would become the foundation of modern astronomy. Kepler's work was a triumph of observation and calculation, and it marked a turning point in celestial cartography. No longer were star maps based on tradition or myth. They were grounded in data, mathematics, and the rigorous pursuit of truth. The Renaissance didn't just give us new tools or theories, it gave us a new way of thinking. It was a time when curiosity triumphed over dogma, and the universe became a place to explore rather than a mystery to fear. Telescopes, mathematical models, and the courage to question old beliefs transformed celestial cartography from an art into a science. And while the maps of the Renaissance might look primitive compared to the 3D models we have today, they were the first steps in a journey that continues to this day. They remind us that progress isn't just about new discoveries, it's about seeing the universe and ourselves in a whole new light. The invention of the telescope in the early 17th century didn't just change how we looked at the stars, it changed how we understood the universe itself. Before this groundbreaking device, astronomers relied on the naked eye and rudimentary tools, limiting their view to what could be seen from Earth's surface. But with the telescope, the heavens were suddenly brought into sharp focus, revealing details that had been hidden for millennia. It was as if the universe had been holding its breath, waiting for humanity to take its first real look. And when we did, everything changed. Galileo Galilei was among the first to turn this new tool toward the night sky, and what he saw was nothing short of revolutionary. Through his telescope, the moon transformed from a smooth, glowing orb into a rugged, cratered landscape. Jupiter, once just a bright point of light, revealed its own family of moons orbiting the giant planet, a discovery that directly challenged the long-held belief that everything in the cosmos revolved around Earth. These observations didn't just expand our understanding of the solar system, they shattered old assumptions, proving that the universe was far more complex and dynamic than anyone had imagined. Galileo's sketches of the moon and his detailed records of planetary motion became some of the first modern celestial maps, blending art and science in a way that captured the imagination of his contemporaries. But the impact of the telescope went beyond individual discoveries. It fundamentally changed the way we mapped the stars. Before its invention, star charts were based on observations made with the naked eye, limiting their accuracy and scope. Telescopes allowed astronomers to see fainter stars, distant nebulae, and even the intricate details of planets. Suddenly, celestial cartography wasn't just about plotting points of light. It was about capturing the intricate structure of the cosmos. For the first time, astronomers could create maps that reflected the true complexity of the universe, filled with galaxies, star clusters, and other wonders that had previously been invisible. This leap in technology also led to a leap in collaboration. As telescopes improved, astronomers began sharing their observations, building on each other's work to create increasingly detailed and accurate star maps. The night sky, once a static backdrop, became a dynamic field of study, with new discoveries being made at an astonishing pace. Telescopes didn't just reveal the universe, they connected humanity to it, turning the act of stargazing into a collective endeavor. It was no longer just about looking up at the stars, it was about exploring them, piece by piece, map by map. Yet, even as telescopes transformed celestial cartography, they also raised new questions. The more we saw, the more we realized how much we didn't know. Nebulae, those faint, glowing clouds in the night sky, turned out to be more than just patches of light. They were vast, swirling clouds of gas and dust, the birthplaces of stars. And the stars themselves, once thought to be fixed in place, were revealed to be moving, drifting through space in a cosmic dance that spanned millions of years. Each new discovery added another layer to the story of the universe, a story that telescopes helped us begin to tell. The invention of the telescope didn't just revolutionize celestial cartography, it revolutionized our relationship with the cosmos. It gave us the tools to explore the universe in ways our ancestors could only dream of, turning the night sky from a mystery into a map. And while the telescopes of Galileo's time might seem primitive compared to the powerful instruments we have today, they were the first steps in a journey that continues to this day. They remind us that every time we look through a telescope, we're not just seeing the stars, we're seeing the legacy of human curiosity, a legacy that began with a simple glass lens and a desire to understand the unknown. When you gaze at the night sky, some of the most captivating sights are those faint, hazy patches that seem to float among the stars. To the naked eye, they might look like nothing more than smudges of light, but through the lens of a telescope, they transform into breathtaking cosmic wonders. These are nebulae, vast clouds of gas and dust that have fascinated astronomers for centuries. What began as simple observations of fuzzy patches has evolved into a deep understanding of these dynamic regions, where stars are born, die, and sculpt the fabric of the universe. The story of how we've mapped nebulae is a journey of curiosity, innovation, and the relentless pursuit of knowledge. In the 18th century, French astronomer Charles Messier set out to catalog these mysterious objects, though not for the reasons you might think. Messier wasn't particularly interested in nebulae themselves. He was a comet hunter, and these faint, cloud-like objects were a nuisance, often mistaken for comets in his telescope. To avoid confusion, he began compiling a list of these non-cometary objects, eventually creating what we now know as the Messier Catalog. Little did he know, his work would become one of the most important contributions to the study of nebulae. Objects like the Orion Nebula, the Crab Nebula, and the Lagoon Nebula were among the first to be recorded, their beauty and complexity only hinted at through the telescopes of the time. Messier's catalog became a cornerstone for future astronomers, providing a roadmap to these celestial wonders. As telescopes improved, so did our understanding of nebulae. What were once thought to be static clouds of gas revealed themselves to be dynamic, ever-changing regions of the cosmos. The Orion Nebula, for example, isn't just a glowing cloud, it's a stellar nursery, a place where new stars are born from swirling clouds of gas and dust. The Crab Nebula, on the other hand, is the remnant of a supernova, a violent explosion that scattered its remnants across space. Each nebula tells a different story, and with every technological advancement, we've been able to uncover more of these stories, piece by piece. The real turning point came with the advent of space-based telescopes, particularly the Hubble Space Telescope. Launched in 1990, Hubble revolutionized our view of the cosmos, capturing images of nebulae with unprecedented clarity and detail. Suddenly, these once fuzzy patches became intricate tapestries of color and light. The pillars of creation in the Eagle Nebula, for instance, became an iconic image, showing towering columns of gas and dust where stars are actively forming. Hubble's images didn't just document nebulae, they transformed them into works of art, revealing the delicate balance of forces that shape these cosmic landscapes. But Hubble's contributions go beyond stunning visuals. By studying the light emitted by nebulae, astronomers have been able to determine their composition, temperature, and even their motion. We now know that nebulae are not just passive observers in the universe, they're active participants, shaping the evolution of galaxies and the birth of new solar systems. The Horsehead Nebula, with its distinctive silhouette, is a prime example of how gas and dust can sculpt themselves into intricate forms, influenced by the radiation and winds from nearby stars. The journey from Messier's simple catalog to Hubble's breathtaking images is a testament to how far we've come in understanding the universe. Nebulae are no longer just mysterious patches of light, they're windows into the processes that drive the cosmos. They remind us that the universe is a place of constant change, where beauty and chaos coexist on a scale that's almost beyond comprehension. And as our tools and techniques continue to evolve, so too will our understanding of these cosmic wonders, revealing even more of the secrets they hold. In the late 18th century, a French astronomer named Charles Messier set out on a mission that would leave an indelible mark on the history of celestial cartography. Messier's goal wasn't to map the heavens for their own sake. He was a comet hunter, and his primary interest lay in discovering these fleeting visitors to our night sky. But as he scanned the heavens with his telescope, he kept encountering faint, fuzzy objects that weren't comets at all. These objects, nebulae, star clusters, and galaxies, were often mistaken for comets, leading to frustration and wasted time. To solve this problem, Messier began compiling a list of these non-cometary objects, meticulously documenting their positions and appearances. What started as a practical tool for comet hunters would eventually become one of the most important catalogs in astronomy, the Messier Catalog. At its core, the Messier Catalog was a practical solution to a specific problem. Messier wasn't trying to revolutionize astronomy. He was simply trying to make his work easier. But in the process, he created something far greater. His catalog, which eventually included 110 objects, became a treasure trove for astronomers. Each entry represented a new piece of the cosmic puzzle, from the swirling arms of the Andromeda Galaxy to the glowing gas of the Orion Nebula. What made the Messier Catalog so groundbreaking wasn't just its content, it was its accessibility. Messier's list provided a clear, organized guide to some of the most fascinating objects in the night sky, making them easier to study and appreciate. For the first time, astronomers and even amateur stargazers had a roadmap to the cosmos. The impact of the Messier Catalog went far beyond its initial purpose. By documenting these objects, Messier inadvertently laid the groundwork for future discoveries. His catalog became a reference point for astronomers, helping them identify and study celestial objects with greater precision. Take, for example, the Crab Nebula, one of the most famous entries in the catalog. When Messier first recorded it, he had no idea it was the remnant of a supernova explosion observed by Chinese astronomers in the year 1054. Today, we know it as a powerful source of radiation and a key to understanding the life cycles of stars. Messier's catalog didn't just preserve these objects for posterity, it opened the door to deeper explorations of their nature and significance. What's remarkable about the Messier Catalog is how it bridged the gap between amateur and professional astronomy. Messier himself was an avid observer, not a theoretical scientist, and his catalog reflected a hands-on approach to stargazing. It was designed to be used, not just studied, and its straightforward format made it accessible to anyone with a telescope. This democratization of celestial knowledge was revolutionary. Suddenly, the wonders of the cosmos weren't reserved for elite astronomers. They were within reach of anyone curious enough to look up. The Messier Catalog became a gateway, inspiring countless stargazers to explore the night sky and fueling a passion for astronomy that continues to this day. But perhaps the greatest legacy of the Messier Catalog is the way it transformed our relationship with the cosmos. By cataloging these objects, Messier didn't just make them easier to find, he made them easier to understand. Each entry in his list was a reminder that the universe is filled with beauty and mystery, waiting to be discovered. From the dazzling Pleiades star cluster to the enigmatic Whirlpool galaxy, the Messier Catalog captured the imagination of astronomers and stargazers alike, proving that even the most practical tools can spark a sense of wonder. Messier's work reminds us that sometimes the greatest discoveries come not from grand ambitions, but from the simple desire to solve a problem and the curiosity to see what lies beyond it. As the 18th century drew to a close, the night sky was no longer just a canvas of stars. It was becoming a vast, uncharted frontier. Enter the Herschel family, a trio of astronomers whose passion and ingenuity would change the way we see the universe forever. At the heart of this family was William Herschel, a musician turned astronomer, whose curiosity led him to build some of the most powerful telescopes of his time. Alongside him was his sister Caroline, a trailblazer in her own right, who not only assisted in their groundbreaking work, but also carved out a legacy as one of the first female astronomers to gain widespread recognition. Together, they embarked on a mission to map the heavens, uncovering thousands of nebulae and star clusters that had never been seen before. Their work didn't just expand our knowledge of the cosmos, it redefined what was possible in celestial cartography. William Herschel's journey into astronomy began almost by accident. Originally a musician, his interest in the stars was sparked by a chance encounter with a book on optics. Intrigued, he began building his own telescopes, crafting them with such precision that they surpassed the capabilities of most instruments of the time. These telescopes became his gateway to the cosmos. In 1781, Herschel made history when he discovered Uranus, the first planet to be identified with a telescope. This discovery catapulted him to fame, but it was only the beginning. With his powerful telescopes, Herschel turned his attention to the deep sky, scanning the heavens for objects that had eluded even the most dedicated observers. What he found was astonishing, a wealth of nebulae and star clusters, each one a testament to the complexity and beauty of the universe. But William's work was far from a solo endeavor. His sister Caroline was an integral part of his astronomical pursuits. While she initially joined him as an assistant, Caroline quickly proved herself to be a skilled observer and meticulous record keeper. She became the first woman to discover a comet, and her contributions to their joint work were invaluable. Caroline's dedication extended beyond the telescope. She compiled and organized their observations, creating detailed catalogs that would later serve as essential resources for astronomers. Her role in the Herschel family's achievements was groundbreaking, not just for the discoveries she made, but for the barriers she broke as a woman in a field dominated by men. Together, the Herschels were a formidable team, their combined talents pushing the boundaries of what was known about the night sky. The Herschel's discoveries were more than just a list of new objects, they were a revelation. Through their observations, they revealed that the universe was far more dynamic and expansive than previously thought. Nebulae, once believed to be mere clouds of light, were shown to be complex structures, some of which were later identified as galaxies beyond our own Milky Way. Star clusters, once thought to be rare, were found to be scattered throughout the cosmos, each one a glittering testament to the processes that shape the universe. The Herschel's work laid the foundation for modern deep sky astronomy, transforming the night sky from a static backdrop into a vibrant, evolving tapestry. What makes the Herschel family's legacy so enduring isn't just the sheer number of their discoveries, it's the way they approached their work. William and Caroline weren't just observers, they were explorers, driven by a relentless curiosity and a desire to understand the universe. Their telescopes weren't just tools, they were extensions of their vision, allowing them to see farther and clearer than anyone before them. And their catalogs weren't just records, they were maps, guiding future generations of astronomers to new frontiers. The Herschels remind us that the pursuit of knowledge isn't just about what we find, it's about how we see the world and how we push the boundaries of what's possible. Their story is a testament to the power of curiosity, collaboration, and the unyielding human spirit to explore the unknown. The invention of photography in the 19th century didn't just change how we documented life on Earth, it completely transformed how we saw the heavens. For centuries, astronomers had relied on hand-drawn sketches and written descriptions to record their observations. These methods, while valuable, were limited by human perception and the constraints of time. But with the advent of photography, a new tool emerged that could capture the night sky in unprecedented detail. This was the birth of astrophotography, a revolutionary technique that allowed astronomers to freeze the cosmos in time, revealing secrets hidden to the naked eye and bringing the wonders of the universe to a wider audience than ever before. One of the earliest breakthroughs in astrophotography came in 1840, when John William Draper, an American scientist, captured the first detailed photograph of the moon. Using a daguerreotype camera, a primitive but groundbreaking device, Draper's image showed the moon's surface in stunning clarity, with its craters and shadows rendered in exquisite detail. This wasn't just a photograph, it was a revelation. For the first time, people could see the moon not as a distant, glowing orb, but as a world with its own rugged terrain. Draper's work opened the door to a new era of celestial cartography, where the night sky could be studied not just through sketches, but through images that preserved every detail with scientific precision. As the technology improved, so did the scope of astrophotography. By the late 19th century, astronomers were using long-exposure photography to capture faint objects like nebulae and star clusters. These images revealed features that were invisible to the naked eye, such as the intricate structure of the Orion Nebula or the delicate tendrils of gas in the Veil Nebula. Suddenly, the night sky wasn't just a collection of points of light. It was a dynamic, evolving landscape filled with complexity and beauty. Astrophotography became a bridge between art and science, offering both aesthetic wonder and scientific insight. One of the most significant contributions of astrophotography was its ability to democratize astronomy. Before photography, stargazing was largely the domain of professional astronomers or wealthy amateurs with access to telescopes. But with the advent of cameras, anyone could capture the night sky. Early pioneers like Henry Draper, John William's son, and Andrew Ainslie Common, a British amateur astronomer, demonstrated that even without formal training, it was possible to produce images that rivaled those of professional observatories. This accessibility helped spark a public fascination with the cosmos, inspiring a new generation of stargazers and amateur astronomers. The impact of astrophotography extended beyond its visual appeal. By capturing light over extended periods, astronomers could study the faintest objects in the sky, uncovering details that would have been impossible to see otherwise. For example, long-exposure images of the Milky Way revealed its true structure not as a smooth band of light, but as a dense collection of stars, gas, and dust. These photographs provided crucial evidence for theories about the size and shape of our galaxy, helping to reshape our understanding of the universe. But perhaps the most profound legacy of astrophotography is the way it connected humanity to the cosmos. A photograph of the stars isn't just a scientific record, it's a moment frozen in time, a reminder of the vastness and mystery of the universe. It's no coincidence that some of the most iconic images in astronomy, like the Hubble Deep Field or the Pillars of Creation, are photographs. These images don't just inform, they inspire, inviting us to look up at the night sky with a sense of wonder and curiosity. Astrophotography didn't just revolutionize celestial cartography, it brought the stars closer to us, making the cosmos a shared experience for anyone willing to look. When the Hubble Space Telescope launched into orbit on April 24, 1990, it marked the beginning of a new chapter in our exploration of the universe. Free from the distortion of Earth's atmosphere, Hubble offered a clarity of vision that ground-based telescopes could only dream of. For over 3 decades, it has been our eye in the sky, capturing images that have not only expanded our scientific knowledge, but also redefined how we see the cosmos. From the swirling arms of distant galaxies to the intricate details of star-forming nebulae, Hubble has turned the night sky into a gallery of cosmic masterpieces, each one a testament to the beauty and complexity of the universe. What sets Hubble apart isn't just its ability to see farther, it's its ability to see deeper. By observing in multiple wavelengths of light, from ultraviolet to near-infrared, Hubble has revealed details that were once invisible to us. Take the Eagle Nebula, for example. Before Hubble, it was just another faint smudge in the sky. But through its lens, we saw the pillars of creation, towering columns of gas and dust where new stars are born. This iconic image didn't just capture the public's imagination. It gave scientists a front-row seat to the processes that shape the universe. Hubble's ability to peer into these stellar nurseries has transformed our understanding of how stars and planetary systems form, turning what was once theoretical into something tangible and awe-inspiring. But Hubble's impact goes beyond stunning visuals. Its observations have been instrumental in answering some of the biggest questions in astronomy. For instance, by measuring the brightness of distant supernova, Hubble helped confirm that the universe is not only expanding but accelerating in its expansion, a discovery that earned the Nobel Prize in Physics in 2011. This revelation fundamentally changed our understanding of the cosmos, introducing the concept of dark energy, a mysterious force driving the universe apart. Hubble's ability to observe these phenomena with such precision has made it an indispensable tool for astronomers, providing data that has reshaped our models of the universe. One of Hubble's most profound contributions has been its ability to make the distant universe accessible. Through its deep field observations, Hubble has peered into regions of space so remote that the light we see from them has traveled for billions of years. The Hubble Deep Field, for example, captured thousands of galaxies in a patch of sky, no larger than a grain of sand held at arm's length. This image is a window into the early universe, showing galaxies as they existed when the cosmos was still in its infancy. It's a humbling reminder of how vast the universe is and how much we still have to learn. Hubble's legacy isn't just measured in scientific discoveries, it's also measured in inspiration. Its images have become cultural touchstones, appearing on everything from textbooks to T-shirts. They've sparked a sense of wonder in people of all ages, reminding us that the universe is not just a place of cold, hard facts, but also one of breathtaking beauty. For many, Hubble's images are the first glimpse of the cosmos they ever see, igniting a lifelong passion for astronomy. In this way, Hubble has done more than map the stars. It's mapped the human imagination, showing us what's possible when we dare to look beyond our world. As we look to the future, with new telescopes like the James Webb Space Telescope taking the stage, Hubble's contributions remind us of the power of exploration. It's not just about the technology or the data, it's about the stories we tell and the connections we make. Hubble has shown us that the universe is a place of endless wonder, filled with mysteries waiting to be uncovered. And perhaps its greatest achievement is this: it has made the cosmos feel a little closer, a little more personal, and a lot more extraordinary. The night sky has always been a map, but with the advent of modern star atlases, that map has become more detailed, precise, and accessible than ever before. Imagine holding a guidebook to the cosmos, one that not only charts the positions of stars, but also pinpoints distant galaxies, nebulae, and other celestial wonders. That's exactly what star atlases like Euronometria and Sky Atlas 2000 offer, a comprehensive roadmap to the universe, designed for both amateur stargazers and professional astronomers. These atlases are more than just collections of star charts. They're tools that bridge the gap between curiosity and discovery, making the vastness of space a little more navigable. At the heart of these modern atlases is their incredible level of detail. Take Euronometria, for example. First published in the 1980s, it was a groundbreaking work that set a new standard for celestial cartography. Unlike earlier star maps, which often focused on just the brightest stars and constellations, Euronometria cataloged over 400,000 stars and thousands of deep sky objects, from glittering star clusters to faint, distant galaxies. Each entry is meticulously plotted, with precise coordinates that allow observers to locate objects with remarkable accuracy. Whether you're using a small backyard telescope or a professional observatory, Euronometria transforms the night sky into a treasure hunt, with every turn of the page revealing something new to explore. But it's not just about quantity, it's about quality too. Modern star atlases are designed with usability in mind. Sky Atlas 2000, another iconic work, is a perfect example. Its charts are beautifully crafted, with clear, easy-to-read labels and symbols that distinguish stars, nebulae, and galaxies at a glance. The atlas also includes helpful features like magnitude scales, which indicate how bright an object will appear, and constellation boundaries, making it easier to navigate the sky's sprawling tapestry. For amateur astronomers, these atlases are like having a personal tour guide to the cosmos, offering tips and insights that turn a casual night of stargazing into an unforgettable adventure. For professional astronomers, star atlases serve a different but equally vital purpose. In a field where precision is everything, these maps provide the foundation for planning observations and conducting research. When astronomers are studying a specific star or galaxy, they rely on atlases to confirm its exact position and identify nearby objects that might affect their data. This level of accuracy is crucial, especially when working with powerful telescopes that can peer billions of light years into space. In a way, star atlases are like the GPS systems of astronomy, ensuring that researchers never lose their way in the vast expanse of the universe. What's truly remarkable about these atlases is how they've adapted to the digital age. Many modern star maps are now available in digital formats, complete with interactive features that make them even more versatile. Imagine zooming in on a specific region of the sky, adjusting the view to match your telescope's field of vision, or even overlaying real-time data from space missions. These digital tools have revolutionized celestial cartography, making it easier than ever for anyone, whether you're a seasoned astronomer or a curious beginner, to explore the night sky. Yet, even with all these advancements, there's something timeless about flipping through the pages of a star atlas. It's a reminder that, despite all the technology at our fingertips, the act of stargazing is still deeply personal. Whether you're tracing the outline of a constellation or marveling at the intricate details of a nebula, these atlases connect us to the cosmos in a way that feels both intimate and profound. They're not just tools for mapping the stars, they're invitations to wonder, to explore, and to discover the universe for yourself. And in that sense, they're as much a part of the journey as the stars themselves. The night sky has always been a source of wonder, but in the digital age, it's also become a playground for exploration, right at our fingertips. Gone are the days when star maps were confined to printed atlases or hand-drawn sketches. Today, with the rise of digital celestial cartography, the cosmos has become more accessible than ever before. Apps like Sky Safari and software like Stellarium have transformed the way we interact with the stars, turning our smartphones and computers into portable planetariums. These tools don't just show us where the stars are, they bring the universe to life, offering real-time views of the night sky, no matter where you are or what time it is. It's a revolution in how we map and understand the cosmos, and it's changing the way we connect with the stars. What makes these digital tools so powerful is their ability to adapt to your location and time. Open an app like Sky Safari, and it instantly knows where you are, adjusting the view of the sky to match your exact position on Earth. Want to see what the stars will look like tonight? Or next week, or even 100 years from now? These apps can simulate it, letting you fast forward or rewind time to explore celestial events like eclipses, planetary alignments, or meteor showers. It's like having a time machine for the universe, giving you a front-row seat to the cosmic dance that's been unfolding for billions of years. For amateur astronomers, this level of accessibility is a game changer, making it easier than ever to plan observations or simply enjoy the night sky. But it's not just about convenience. Digital celestial cartography is also pushing the boundaries of what we can discover. Software like Stellarium doesn't just show the stars, it layers in detailed information about planets, moons, asteroids, and even distant galaxies. With a few clicks, you can zoom in on Jupiter's swirling storms, track the path of a comet, or explore the intricate structure of a nebula. These tools are packed with data, from star magnitudes and constellation boundaries to the latest discoveries from space missions. They're not just maps, they're interactive encyclopedias of the cosmos, designed to educate and inspire. Whether you're a seasoned astronomer or a curious beginner, they offer a way to dive deeper into the universe without ever leaving your couch. One of the most exciting aspects of digital cartography is how it's democratizing astronomy. In the past, studying the stars required access to expensive equipment or specialized knowledge. But now, anyone with a smartphone or computer can explore the night sky. Apps like Sky View or Star Walk guide you through the constellations, pointing out key objects and explaining their significance. They're like having a personal astronomy tutor in your pocket, making stargazing more approachable and engaging for people of all ages. This accessibility is sparking a new wave of interest in astronomy, encouraging more people to look up and wonder about the universe. Digital tools are also transforming the way professional astronomers work. Advanced software can process vast amounts of data from telescopes, creating detailed 3D models of the cosmos that were once impossible to visualize. These models allow scientists to study the structure of galaxies, map the distribution of dark matter, or simulate the birth of stars in unprecedented detail. It's a level of precision and insight that's reshaping our understanding of the universe, helping us answer questions that have puzzled astronomers for centuries. And because this data is often shared online, it's fostering collaboration across the globe, connecting researchers and amateurs alike in a shared quest to explore the cosmos. Yet, for all their sophistication, these digital tools still capture the magic of stargazing. They remind us that the universe is vast, mysterious, and full of beauty. Whether you're using an app to identify a constellation or exploring a 3D model of a distant galaxy, these tools bring the cosmos closer, making it feel a little less distant and a lot more personal. They're not just changing how we map the stars, they're changing how we see ourselves in the universe. And in doing so, they're keeping alive that timeless sense of wonder that has always drawn us to the night sky. For centuries, star maps have been flat, two-dimensional representations of the night sky, beautiful, yes, but limited in their ability to capture the true depth and scale of the universe. Imagine trying to describe the Grand Canyon using only a photograph taken from above. You'd miss the towering cliffs, the winding river, the sheer vastness of it all. That's the challenge with traditional star maps. They show us where objects are, but not how far apart they really are or how they're arranged in three-dimensional space. Enter 3D star maps, a revolutionary leap in celestial cartography that transforms our flat, static charts into dynamic, immersive models of the cosmos. These maps don't just plot stars, they reveal the universe in all its depth, showing us the true distances and relationships between stars, nebulae, and galaxies. It's like trading a black and white sketch for a full-color, high-definition movie. The development of 3D star maps owes much to advancements in technology, particularly in data collection and computer modeling. Astronomers have long known that the night sky is a three-dimensional space, but measuring the exact distances to stars and other objects was a monumental challenge. Enter parallax, a technique that uses the apparent shift in a star's position when viewed from different points in Earth's orbit to calculate its distance. This method, combined with data from space missions like the European Space Agency's Gaia satellite, has allowed scientists to map the positions of billions of stars with astonishing precision. Gaia, for instance, has measured the distances to over 1 billion stars, creating a detailed 3D map of our Milky Way galaxy that's unparalleled in its scope and accuracy. These maps don't just show us where stars are, they show us how they're moving, how they're clustered, and how they're distributed across the galaxy. But 3D star maps aren't just about plotting points in space, they're about revealing the structure and dynamics of the universe. Take the Milky Way, for example. In a 2D map, our galaxy appears as a flat band of light stretching across the night sky. But in a 3D map, it transforms into a sprawling, spiral-shaped structure, with vast arms of stars, gas, and dust swirling around a dense, central core. These maps show us how stars are born in the dense clouds of nebulae, how they migrate over time, and how they interact with one another. They reveal the intricate dance of galaxies, the vast voids between them, and the cosmic web that connects everything. It's a level of detail and insight that's simply impossible with traditional star maps. One of the most exciting applications of 3D star maps is their ability to help us explore beyond our own galaxy. By mapping the positions and movements of stars in nearby galaxies, Astronomers can study how these systems evolve over time. For instance, 3D maps of the Andromeda Galaxy, our closest galactic neighbor, have revealed that it's on a collision course with the Milky Way, a cosmic event that will unfold billions of years from now. These maps also allow us to visualize the large-scale structure of the universe, showing how galaxies are clustered into vast filaments and sheets separated by enormous voids. It's a perspective that shifts our understanding of the cosmos from a collection of isolated points to a dynamic, interconnected web of matter and energy. What makes 3D star maps so powerful is their ability to make the universe feel tangible. When you look at a traditional star map, you're seeing a flat representation of something that's inherently three-dimensional. But with a 3D map, you can zoom in, rotate, and explore the cosmos from any angle. You can see how the stars in Orion's belt are actually hundreds of light-years apart, or how the Pleiades star cluster forms a tight, glittering group in space. These maps bring the universe to life, transforming abstract concepts into something you can almost reach out and touch. And with the rise of virtual reality and augmented reality, this experience is becoming even more immersive. Imagine putting on a VR headset and flying through the Milky Way, or using an AR app to project a 3D star map onto your living room ceiling. It's a level of engagement that's redefining how we interact with the cosmos. Yet, for all their sophistication, 3D star maps also remind us of the challenges we still face in understanding the universe. Mapping the cosmos in 3 dimensions requires not just technology, but creativity and imagination. It forces us to think beyond the flat plane of the night sky and consider the vast, complex structure of space. These maps are more than just tools. They're invitations to explore, to wonder, and to ask new questions. They show us that the universe is not just a collection of stars, but a dynamic, ever-changing landscape, one that we're only beginning to understand. And as our technology continues to evolve, so too will our ability to map and explore this extraordinary expanse. The story of 3D star maps is still being written, and the next chapter promises to be as awe-inspiring as the last. The Milky Way, our cosmic home, is a sprawling, intricate galaxy, a vast collection of stars, gas, and dust that stretches across 100,000 light-years. But mapping this colossal structure has been anything but simple. Unlike looking at a distant galaxy, where we can see its shape and structure from the outside, we're embedded within the Milky Way, making it far harder to piece together its full picture. Imagine trying to map a forest while standing in the middle of it, surrounded by trees in every direction. That's the challenge astronomers have faced for centuries as they've worked to chart our galactic neighborhood. From early sketches based on limited observations to today's cutting-edge surveys, the story of mapping the Milky Way is a testament to human ingenuity and persistence. In the early days of astronomy, mapping the Milky Way was a game of educated guesses and careful observation. Without the ability to see beyond our own galaxy, astronomers relied on what they could observe from Earth stars, nebulae, and the faint band of light that gives the Milky Way its name. One of the first major breakthroughs came in the late 18th century, when William Herschel, the same astronomer who discovered Uranus, attempted to map the Milky Way's structure. Using his powerful telescopes, Herschel counted stars in different regions of the sky, creating a rough sketch of the galaxy's shape. His map depicted the Milky Way as a flattened disk with the sun near its center, a groundbreaking idea at the time, even if it wasn't entirely accurate. Herschel's work laid the foundation for future astronomers, showing that the Milky Way wasn't just a random scattering of stars, but a structured system with a distinct shape. As technology advanced, so did our understanding of the Milky Way. In the early 20th century, astronomer Harlow Shapley made a pivotal discovery that shifted our perspective. By studying the distribution of globular clusters, dense groups of stars orbiting the galactic center, Shapley determined that the Sun was not at the center of the Milky Way, as Herschel had believed. Instead, he found that our solar system lies about 2/3 of the way out from the center, in one of the galaxy's spiral arms. This realization was a game changer, revealing that the Milky Way is far more complex than a simple disk. It's a dynamic, evolving system, with stars, gas, and dust swirling around a dense, central core. But mapping the Milky Way's spiral structure proved to be an even greater challenge. Unlike other galaxies, where spiral arms are clearly visible from the outside, our view of the Milky Way is obscured by dust and gas that block visible light. To overcome this, astronomers turn to radio waves, which can penetrate these obstacles and reveal what lies beyond. In the mid-20th century, radio telescopes began mapping the distribution of hydrogen gas, the primary component of the galaxy's spiral arms. These observations confirmed that the Milky Way is a barred spiral galaxy, with a central bar-shaped structure surrounded by sweeping arms of stars and gas. Each arm is a stellar nursery, where new stars are born from dense clouds of gas and dust, adding to the galaxy's ever-changing tapestry. One of the most intriguing features of the Milky Way is its central region, home to a supermassive black hole known as Sagittarius A. This colossal object, with a mass 4 million times that of the Sun, exerts a powerful gravitational pull, shaping the orbits of stars and gas clouds around it. Mapping this region has been a monumental task, requiring some of the most advanced telescopes ever built. Using infrared and radio observations, astronomers have been able to peer through the thick dust that obscures the galactic center, revealing a chaotic, high-energy environment where stars whip around the black hole at incredible speeds. These observations have not only deepened our understanding of the Milky Way's core, but also provided crucial insights into how supermassive black holes influence their host galaxies. Today, projects like the European Space Agency's Gaia mission are taking our understanding of the Milky Way to new heights. Gaia is mapping the positions, distances, and motions of over 1 billion stars, creating the most detailed 3D map of our galaxy ever made. This data is revealing the Milky Way's structure in unprecedented detail, from the intricate patterns of its spiral arms to the subtle warping of its disk caused by interactions with nearby galaxies. Gaia's map is more than just a snapshot of the galaxy. It's a dynamic portrait that shows how the Milky Way is evolving over time, with stars moving, clusters forming, and the galaxy itself slowly rotating. Mapping the Milky Way isn't just an academic exercise, it's a journey of discovery that connects us to our cosmic home. Each new map, each observation, brings us closer to understanding the galaxy we call home, its past, its present, and its future. It's a reminder that the Milky Way isn't just a collection of stars. It's a living, breathing system, shaped by the forces of gravity, time, and the endless cycle of star birth and death. And as our tools and techniques continue to evolve, so too will our ability to explore and understand this extraordinary galaxy. The story of mapping the Milky Way is far from over. It's a story that's still being written, one star at a time. When we look up at the night sky, we're seeing only a fraction of what's out there, just the stars, galaxies, and nebulae that emit or reflect light. But what about the parts of the universe we can't see? Enter dark matter, an invisible, mysterious substance that makes up roughly 85% of all matter in the cosmos. It doesn't emit, absorb, or reflect light, yet its presence is felt everywhere, shaping the very fabric of the universe. This unseen force is one of the greatest mysteries in modern astronomy, and mapping its distribution has become one of the most exciting frontiers in celestial cartography. By studying its gravitational effects, astronomers are uncovering the hidden structure of the cosmos, revealing a universe far more intricate and strange than we ever imagined. So, how do you map something you can't see? The answer lies in gravity. Dark matter may be invisible, but its gravitational pull is undeniable. It bends the path of light from distant galaxies, a phenomenon known as gravitational lensing. By observing how light from these galaxies is distorted, astronomers can infer the presence and distribution of dark matter. Imagine looking through a glass of water and seeing a straw appear bent. It's a similar effect, but on a cosmic scale. This technique has allowed scientists to create detailed maps of dark matter, showing how it clumps together in vast halos around galaxies and stretches across the universe in intricate webs. One of the most striking discoveries from these maps is the cosmic web, a sprawling network of dark matter that connects galaxies and galaxy clusters. This web isn't just a random tangle, it's a carefully organized structure, formed over billions of years as gravity pulled dark matter into filaments and nodes. These filaments act like highways, guiding the movement of galaxies and shaping the large-scale structure of the universe. It's a bit like looking at a map of a city's subway system, with dark matter as the tracks and galaxies as the stations. Without dark matter, the universe, as we know it, simply wouldn't exist. It's the scaffolding that holds everything together, the unseen hand that guides the cosmos. But dark matter isn't just a passive player in the universe, it's actively shaping the evolution of galaxies. By mapping its distribution, astronomers have discovered that galaxies with more dark matter tend to form stars more efficiently. This invisible substance acts as a gravitational anchor, pulling in gas and dust that eventually collapse to form new stars. Without dark matter, galaxies would lack the gravitational pull needed to hold themselves together, and the universe would be a far emptier, darker place. It's a reminder that even though we can't see dark matter, its influence is everywhere, from the smallest star systems to the largest galaxy clusters. Mapping dark matter has also shed light on one of the biggest mysteries in cosmology, the ultimate fate of the universe. By studying how dark matter interacts with visible matter, astronomers have been able to refine models of cosmic expansion and dark energy, the mysterious force driving the universe apart. These maps provide crucial clues about the balance of forces that will determine whether the universe continues to expand forever, collapses back on itself, or reaches some other, unknown destiny. It's a question that goes to the very heart of our existence, and dark matter is at the center of it all. What's truly remarkable about these maps is how they've transformed our understanding of the cosmos. They've shown us that the universe isn't just what we can see. It's a vast, interconnected network of visible and invisible forces, each playing a crucial role in the cosmic dance. Dark matter may be elusive, but through the power of observation, mathematics, and technology, we're slowly piecing together its story. It's a story that challenges our assumptions, expands our horizons, and reminds us that the universe is full of surprises. As we continue to map the invisible, we're not just exploring the cosmos, we're uncovering the hidden layers of reality itself. For centuries, the idea of planets beyond our solar system was the stuff of science fiction, a tantalizing possibility, but one that seemed forever out of reach. That all changed in the early 1990s when astronomers made a groundbreaking discovery, the first confirmed exoplanet orbiting a sun-like star. Since then, the field of exoplanet research has exploded, with thousands of these distant worlds now mapped and cataloged. But exoplanet mapping isn't just about finding new planets, it's about exploring the possibilities of life beyond Earth and expanding our understanding of the universe. This is celestial cartography on an entirely new scale, charting worlds that are light years away and uncovering the secrets they hold. One of the most fascinating aspects of exoplanet mapping is the sheer variety of worlds it has revealed. From scorching, gas giants orbiting close to their stars to icy, rocky planets in the frozen depths of space, the diversity of exoplanets is staggering. Some are so hot they rain molten metal, while others are shrouded in thick atmospheres of hydrogen and helium. Then there are the so-called super-Earths, planets larger than our own but smaller than Neptune, which could potentially harbor the conditions needed for life. Mapping these worlds isn't just about pinpointing their locations. It's about understanding their composition, atmosphere, and potential habitability. Each discovery adds a new piece to the puzzle, helping us build a more complete picture of what's out there. But mapping exoplanets comes with its own set of challenges. Unlike stars, which emit their own light, planets are much harder to detect because they don't shine on their own. Instead, astronomers rely on indirect methods to find them. One of the most common techniques is the transit method, which involves observing a star's brightness over time. When a planet passes in front of its star, it causes a slight dip in the star's light, a telltale sign that a planet is present. This method has been incredibly successful, leading to the discovery of thousands of exoplanets, including some in the habitable zone, where conditions might be right for liquid water and possibly life to exist. Another powerful tool in the exoplanet mapper's toolkit is the radial velocity method. This technique measures the tiny wobbles in a star's motion caused by the gravitational pull of an orbiting planet. These wobbles shift the star's light slightly, revealing the planet's presence and even providing clues about its mass and orbit. Together, these methods have allowed astronomers to map exoplanets with remarkable precision, even though they're often trillions of miles away. Perhaps the most exciting development in exoplanet mapping is the search for biosignatures, chemical signs that could indicate the presence of life. By analyzing the light that passes through a planet's atmosphere during a transit, astronomers can detect gases like oxygen, methane, and carbon dioxide. These gases, in the right combinations, could hint at biological activity. Missions like NASA James Webb Space Telescope are taking this search to the next level, with the ability to study the atmospheres of distant worlds in unprecedented detail. It's a long shot, but the possibility of finding signs of life on another planet is a driving force behind much of this work. Of course, mapping exoplanets isn't just about the science, it's about the stories these worlds tell. Each discovery is a reminder of how vast and varied the universe is, and how much we still have to learn. Exoplanet mapping is pushing the boundaries of what we thought was possible, transforming our understanding of planetary systems and our place within them. It's a field that's as much about imagination as it is about observation, a blend of curiosity and technology that's opening up new frontiers in the cosmos. And as our tools and techniques continue to evolve, so too will our ability to explore these distant worlds, bringing us closer than ever to answering one of humanity's oldest questions: are we alone? When we zoom out from individual stars and galaxies, the universe reveals a structure far grander and more intricate than anything we could imagine. Picture this: a vast, interconnected network of galaxies, clusters, and filaments woven together by gravity and stretching across billions of light years. This is the cosmic web, the large-scale architecture of the universe, and mapping it has become one of the most ambitious projects in modern astronomy. Far from being a random scattering of celestial objects, the cosmos is organized into this sprawling, web-like pattern, with dense clusters of galaxies connected by gossamer threads of dark matter and gas, separated by enormous voids of near-empty space. Understanding this structure isn't just about creating a map, it's about unraveling the story of how the universe evolved, from the Big Bang to the present day. One of the most powerful tools for mapping the cosmic web is something called redshift surveys. As the universe expands, light from distant galaxies stretches, shifting toward the red end of the spectrum. By measuring this redshift, astronomers can determine how far away a galaxy is and how fast it's moving. Over the past few decades, projects like the Sloan Digital Sky Survey have used this technique to map the positions of millions of galaxies, creating a three-dimensional picture of the universe on the largest scales. What these surveys reveal is breathtaking. Galaxies aren't scattered randomly, but are clustered into dense knots, linked by filaments and separated by vast, empty regions. It's like looking at a cosmic city with galaxies as the buildings, filaments as the streets, and voids as the open spaces in between. But the cosmic web isn't just a static structure. It's dynamic, evolving over billions of years. At its heart lies dark matter, the invisible scaffolding that shapes the universe. Dark matter's gravitational pull draws ordinary matter, gas, dust, and stars into the filaments and nodes of the web, forming galaxies and galaxy clusters. Over time, these clusters grow, merging and pulling in more material, while the voids between them become emptier. It's a process driven by gravity, but also by the mysterious force of dark energy, which acts as a counterbalance, pushing the universe apart and accelerating its expansion. By mapping the cosmic web, astronomers can trace the history of this cosmic tug of war, uncovering clues about how the universe has changed since its birth. What's truly remarkable about these maps is how they reveal the universe's underlying order. The cosmic web isn't just a random pattern, it's a reflection of the initial conditions set by the Big Bang. Tiny fluctuations in the density of matter in the early universe, imprinted as faint ripples in the cosmic microwave background, grew over time, amplified by gravity, to form the structures we see today. In a sense, the cosmic web is a fossil record of the universe's infancy, a snapshot of how it looked just moments after its birth. By studying it, we're not just mapping the present, we're peering into the past, reconstructing the history of the cosmos itself. This exploration isn't just about satisfying scientific curiosity, it's about understanding our place in the universe. The cosmic web reminds us that everything we see, from the stars in our night sky to the galaxies billions of light years away, is part of a vast, interconnected system. It's a humbling perspective, one that highlights both the scale of the cosmos and the ingenuity of the human mind. Through the power of observation, mathematics, and technology, we've been able to map this invisible structure, turning what was once a mystery into a roadmap of the universe. And as our tools continue to improve, so too will our ability to explore this extraordinary web, revealing even more of its secrets and deepening our understanding of the cosmos we call home. As we venture beyond Earth, the stars become more than just distant points of light. They become our guides, our landmarks, and even our lifelines. Space exploration, Whether it's a crewed mission to the moon or an unmanned probe hurtling toward the outer reaches of the solar system, depends on one critical tool: accurate star maps. These celestial roadmaps are the backbone of navigation in the void of space, ensuring that every spacecraft, from the earliest Apollo missions to the most advanced interplanetary probes, can find its way through the cosmos. Without the precision of celestial cartography, space exploration, as we know it, simply wouldn't be possible. Take, for example, the Apollo missions of the 1960s and 70s. For the first time in history, humans were traveling beyond Earth's orbit, venturing into the unknown. But how did they navigate the vast expanse between Earth and the Moon? The answer lies in a combination of star charts, onboard computers, and a technique called celestial navigation. Astronauts used a device called a sextant to measure the angles between stars and the Moon, feeding this data into their computers to calculate their position in space. It was a high-tech version of what sailors had been doing for centuries, using the stars to guide their ships across the oceans. In the case of Apollo, those stars were the same ones mapped by ancient astronomers, proving that the tools of celestial cartography are as timeless as the stars themselves. Fast forward to today, and the role of celestial cartography in space exploration has only grown more critical. Modern missions, like NASA Voyager probes or the Mars rovers, rely on incredibly precise star maps to navigate the solar system. These spacecraft use something called a star tracker, a device that identifies specific stars in its field of view and compares them to an onboard catalog. By pinpointing its exact orientation in space, the spacecraft can adjust its trajectory with pinpoint accuracy, even across millions of miles. It's a bit like using a cosmic GPS, where the stars serve as fixed reference points in an otherwise featureless void. Without these maps, even the most advanced spacecraft would be flying blind, unable to find their way to distant planets or asteroids. But it's not just about getting from point A to point B. Celestial cartography also plays a key role in scientific discovery. When a probe like New Horizons flew past Pluto in 2015, its trajectory had to be calculated with extreme precision to ensure it captured the best possible images and data. This required not just a map of the stars, but also detailed knowledge of Pluto's position and movement. By combining star maps with planetary ephemerides tables that predict the positions of celestial objects, scientists were able to guide New Horizons on its historic journey, revealing a world far more complex and fascinating than anyone had imagined. In this way, celestial cartography doesn't just support exploration, it enables discovery, helping us uncover the secrets of distant worlds. Looking to the future, the importance of star mapping will only increase as we set our sights on more ambitious goals, like crewed missions to Mars or even interstellar travel. Imagine navigating a spacecraft to a star system light years away, where the stars themselves are unfamiliar. In such a scenario, our ability to map the cosmos with precision will be more critical than ever. Projects like the European Space Agency's Gaia mission, which is creating a three-dimensional map of over 1 billion stars, are laying the groundwork for these future journeys. By charting the positions, distances, and motions of stars across the Milky Way, Gaia is providing the data we'll need to explore beyond our solar system, turning science fiction into science fact. Space exploration is, at its core, a story of human ingenuity and curiosity. It's about pushing the boundaries of what's possible, venturing into the unknown, and discovering what lies beyond the horizon. And at every step of the way, celestial cartography has been there, guiding us through the darkness and helping us find our way. Whether it's a lunar module descending to the moon's surface or a probe skimming past the rings of Saturn, the stars are our constant companions, lighting the path to new frontiers. In the end, space exploration isn't just about the destinations we reach, it's about the journey and the maps that make it possible. The future of celestial cartography is not just about where we've been, it's about where we're going. With every leap in technology, our ability to map the cosmos grows, revealing new layers of the universe that were once beyond our reach. Today, we stand on the brink of a new era, where cutting-edge tools and groundbreaking techniques are transforming how we explore and understand the stars. From next-generation telescopes to the power of artificial intelligence, the future of celestial cartography is poised to rewrite what we thought was possible. One of the most exciting developments on the horizon is the rise of next-generation telescopes. Instruments like the James Webb Space Telescope, which launched in late 2021, are already revolutionizing our view of the universe. With its ability to observe in infrared light, Webb can peer through cosmic dust and gas, uncovering hidden details of star formation, distant galaxies, and even the atmospheres of exoplanets. But Webb is just the beginning. Upcoming projects like the Extremely Large Telescope, set to be the largest optical telescope ever built, will allow us to see farther and clearer than ever before. These telescopes aren't just tools for observation, they're gateways to discovery, offering a chance to explore the universe in ways we've only dreamed of. Artificial intelligence is another game-changer in the field of celestial cartography, with the sheer volume of data being collected by telescopes and space missions. Analyzing it all manually would be impossible. Enter AI, which can sift through terabytes of data in seconds, identifying patterns and anomalies that might otherwise go unnoticed. Machine learning algorithms are already being used to classify galaxies, detect exoplanets, and even predict the behavior of stars. But AI's potential goes beyond data analysis. It's also helping us create more accurate and detailed star maps. By combining observations from multiple sources, AI can generate 3D models of the cosmos that are more precise than ever before, opening up new possibilities for exploration and discovery. Then there's the growing role of space-based observatories. While ground-based telescopes have their limits due to Earth's atmosphere, space-based instruments can operate with unparalleled clarity. Missions like the European Space Agency's Euclid and Nancy Grace Roman Space Telescope are set to map the universe in unprecedented detail, focusing on dark matter, dark energy, and the large-scale structure of the cosmos. These observatories will provide data that could reshape our understanding of the universe, answering questions about its origins, evolution, and ultimate fate. But perhaps the most exciting aspect of the future of celestial cartography is its potential to bring the universe closer to everyone. Advances in virtual reality and augmented reality are making it possible for anyone to explore the cosmos from their living room. Imagine donning a VR headset and flying through a 3D map of the Milky Way, or using an AR app to project constellations onto your ceiling. These technologies are democratizing access to the stars, turning stargazing into an immersive, interactive experience. It's a future where the wonders of the universe aren't just for scientists, they are for everyone. As we look ahead, one thing is clear: the future of celestial cartography is about more than just mapping the stars. It's about expanding our horizons. With every new tool and technique, we're uncovering more of the universe's secrets, from the smallest exoplanets to the largest cosmic structures. And as we continue to push the boundaries of what's possible, we're not just charting the cosmos, we're redefining our place within it. The stars have always been our guides, and with the innovations on the horizon, they'll continue to light the way to new discoveries, new questions, and new adventures in the vast expanse of space. When we think of celestial cartography, it's easy to picture professionals in observatories, hunched over massive telescopes or analyzing complex data. But the truth is, some of the most groundbreaking discoveries in astronomy have come from a different group of stargazers, amateur astronomers and citizen scientists. These passionate individuals, armed with curiosity and often modest equipment, have played a vital role in mapping the stars and uncovering the secrets of the cosmos. From backyard telescopes to online platforms, amateur astronomers are proving that you don't need a PhD to make a meaningful contribution to science. One of the most remarkable examples of this is Galaxy Zoo, a citizen science project that invites anyone with an internet connection to help classify galaxies. Launched in 2007, Galaxy Zoo asked volunteers to analyze images from the Sloan Digital Sky Survey, categorizing galaxies based on their shapes. The response was overwhelming. Within the first year, over 150,000 people participated, classifying millions of galaxies. What's truly astonishing is how these volunteers, many with no formal training in astronomy, made discoveries that professionals had missed. For instance, Galaxy Zoo participants identified a rare type of galaxy known as green peas, small, compact galaxies with intense star formation. This discovery opened up new avenues of research, showing that citizen science isn't just a fun way to engage the public, it's a powerful tool for discovery. But Galaxy Zoo is just one example of how amateur astronomers are shaping our understanding of the universe. The American Association of Variable Star Observers, or AVSO, has been harnessing the power of citizen science for over a century. Founded in 1911, the AVSO collects data from amateur astronomers around the world, tracking the brightness of variable stars that change in brightness over time. These observations are crucial for understanding stellar evolution, and they've led to countless scientific papers and discoveries. What's inspiring about the AVSO is its collaborative spirit. Whether you're using a high-end telescope or a simple pair of binoculars, your observations matter. It's a reminder that astronomy is a shared endeavor, one that thrives on the contributions of people from all walks of life. What makes amateur astronomy so powerful is its accessibility. Unlike many scientific fields, astronomy is one where you can make real contributions with relatively simple tools. A small telescope, a camera, and a bit of patience can lead to discoveries that add to our collective knowledge. Take the case of Japanese amateur astronomer Koichi Itagaki, who in 2018 discovered a supernova, a massive stellar explosion, using nothing more than his backyard telescope. His discovery was later confirmed by professional observatories, highlighting how amateurs and professionals can work together to push the boundaries of what we know. Digital technology has also opened up new opportunities for amateur astronomers. Platforms like Zooniverse host a variety of citizen science projects, from mapping the surfaces of Mars to identifying exoplanets. These projects allow anyone, anywhere, to contribute to cutting-edge research, often from the comfort of their own home. It's a testament to how technology is democratizing science, breaking down barriers, and making the cosmos accessible to everyone. And the impact of these projects goes beyond the data they produce. They inspire a sense of wonder and curiosity, reminding us that the universe is a place of endless discovery. The contributions of amateur astronomers and citizen scientists are a reminder that science isn't just for the experts, it's for everyone. Whether you're classifying galaxies online, tracking variable stars, or simply marveling at the night sky, you're part of a global community of explorers. Together, we're mapping the stars, uncovering the mysteries of the universe, and proving that the cosmos belongs to us all. It's a story of collaboration, curiosity, and the enduring human spirit to explore the unknown. And in a world that often feels divided, it's a powerful reminder of what we can achieve when we look up and work together. The stars have always been more than just points of light in the sky. They are storytellers, navigators, and teachers, woven into the fabric of countless cultures across the globe. While modern astronomy often focuses on the scientific aspects of celestial cartography, the cultural perspectives on the stars reveal a rich tapestry of human imagination and ingenuity. From the indigenous sky lore of the Americas to the ancient navigational skills of Polynesian voyagers, every culture has its own way of mapping the heavens, offering unique insights into how people have understood and connected with the cosmos throughout history. These diverse traditions remind us that the night sky is not just a scientific frontier, it's a canvas for human creativity, spirituality, and survival. In the vast expanse of the Pacific Ocean, the Polynesians developed one of the most sophisticated systems of celestial navigation ever known. Without the aid of modern instruments, these master navigators used the stars, the sun, and even the subtle patterns of ocean swells to chart their way across thousands of miles of open water. The Polynesian star compass, for example, divides the horizon into 32 directional points, each aligned with specific stars or constellations. By memorizing the rising and setting positions of these celestial markers, navigators could determine their course with astonishing precision. This knowledge wasn't just practical, it was sacred, passed down through generations, and deeply intertwined with Polynesian mythology and identity. The stars weren't just tools, they were guides, ancestors, and living connections to the past. On the other side of the world, indigenous cultures in the Americas have their own rich traditions of celestial cartography. For the Inca, the Milky Way was not just a band of light, it was a celestial river, a reflection of the terrestrial rivers that nourished their civilization. They saw constellations not as static patterns, but as dynamic beings, with the dark spaces between stars forming shapes like animals and mythological figures. These constellations, known as dark cloud constellations, were used to mark the seasons, guide agricultural practices, and tell stories of creation and morality. Similarly, the Navajo people of North America view the night sky as a living entity, with constellations like the Hero Twins representing the balance of cosmic forces. For these cultures, the stars are not distant objects to be studied, they are an integral part of life, woven into the very fabric of their worldviews. In Australia, indigenous astronomy offers yet another perspective on the cosmos. Aboriginal cultures have some of the oldest continuous traditions of stargazing, with stories and star maps that date back tens of thousands of years. The emu in the sky, for example, is a constellation formed not by stars, but by the dark patches of the Milky Way. This celestial emu is deeply connected to the land, with its position in the sky signaling the best times for hunting and gathering. These traditions are more than just astronomical knowledge, they are living narratives, passed down through song, dance, and art that connect people to their ancestors and their environment. The night sky, for indigenous Australians, is a storybook, a calendar, and a guide, all in one. Even in ancient China, celestial cartography was imbued with cultural and philosophical significance. The Chinese divided the sky into 28 lunar mansions, each associated with a specific constellation and used to track the moon's path through the heavens. These mansions were not just astronomical markers, they were part of a larger system of thought that linked the cosmos to human affairs, from agriculture to governance. The Chinese also saw the stars as a reflection of earthly harmony, with celestial events like eclipses and comets interpreted as signs of cosmic balance or imbalance. This holistic view of the universe, where the heavens and the earth are deeply interconnected, offers a perspective that is both poetic and profoundly insightful. What's striking about these cultural perspectives is how they enrich our understanding of the cosmos. While modern science has given us tools to measure and map the universe with incredible precision, these traditions remind us that the stars are more than just physical objects. They are symbols, stories, and sources of meaning. They show us that celestial cartography is not just about charting the heavens, it's about understanding our place within them. By exploring these diverse ways of seeing the stars, we gain not only a deeper appreciation for the night sky, but also a greater sense of connection to the people and cultures that have gazed up at it for millennia. The stars, it turns out, are not just a map of the universe, they're a map of humanity itself. Celestial cartography has always been more than a scientific endeavor, it's a celebration of beauty, a merging of art and astronomy that transforms the night sky into a canvas of wonder. Think about it. Every star map, whether etched on ancient clay tablets or rendered in vivid digital detail, is not just a tool for understanding the cosmos, but also a work of art. These maps capture the imagination, blending the precision of science with the creativity of human expression. From the intricate illustrations of medieval manuscripts to the breathtaking images from modern telescopes, the art of celestial cartography reveals the universe as a place of both mystery and majesty. Take, for instance, the celestial globes of the Renaissance. These ornate, handcrafted spheres were more than just scientific instruments, they were masterpieces of artistry. Crafted with meticulous care, they depicted the constellations not as mere points of light, but as vivid mythological figures, their stories woven into the very fabric of the sky. These globes were often adorned with gold leaf, vibrant colors, and intricate patterns, turning them into objects of both utility and beauty. They remind us that the stars have always been a source of inspiration, not just for scientists, but for artists, poets, and dreamers. Fast forward to the 19th century, and you'll find another striking example of art meeting astronomy, the celestial atlases of Edouard Biot and John Herschel. These works were more than collections of star charts, they were visual feasts, filled with delicate engravings that captured the ethereal glow of nebulae and the shimmering brilliance of star clusters. Herschel's illustrations of the Orion Nebula, for example, weren't just scientific records, they were attempts to convey the awe and wonder of the cosmos. Through their art, these astronomers invited others to see the universe not just as a collection of points, but as a place of breathtaking beauty. In the modern era, the artistic side of celestial cartography has only grown more vibrant. Consider the Hubble Space Telescope's iconic images, like the Pillars of Creation or the Veil Nebula. These aren't just scientific observations, they're cosmic portraits, revealing the intricate textures and vibrant colors of the universe. Artists and scientists often collaborate to enhance these images, using color to highlight different wavelengths of light, or adding artistic touches to emphasize the awe-inspiring scale of these celestial phenomena. The result is a blend of science and art that captures the imagination and brings the cosmos to life in ways that raw data alone never could. But it's not just professionals who are creating these works of art. Amateur astronomers and artists around the world are using their talents to celebrate the beauty of the stars. From hand-painted star maps to digital animations that simulate the birth of galaxies, these creators are proving that celestial cartography is as much about inspiration as it is about exploration. Their work reminds us that the night sky is a universal muse, inviting us to see the cosmos not just through the lens of science, but through the eyes of an artist. At its heart, the art of celestial cartography is a testament to the enduring human desire to connect with the universe. It's a reminder that the stars are more than just distant objects, they're symbols of wonder, curiosity, and the boundless creativity of the human spirit. Whether through ancient star charts or modern digital renderings, these artistic creations invite us to look up and see the cosmos not just as it is, but as it could be, a place of endless beauty waiting to be explored and celebrated. The stars have always been more than just celestial objects, they've been storytellers, weaving their way into the fabric of human imagination across centuries. From ancient myths to modern science fiction, the night sky has served as a backdrop for some of the most compelling narratives ever told. Whether as guides for heroes, symbols of destiny, or gateways to other worlds, star maps and celestial imagery have shaped the way we tell stories, blending science and creativity in ways that continue to inspire. Take Dante Alighieri's Divine Comedy, written in the early 14th century. In this epic poem, the heavens aren't just a setting, they're a map of the soul's journey. Dante's vision of the cosmos, with its concentric spheres representing different realms of paradise, mirrors the medieval understanding of the universe. The stars in this context aren't just points of light, they're markers of divine order guiding the poet through his spiritual ascent. Dante's celestial cartography is both poetic and profound, showing how the stars can serve as a metaphor for human aspiration and the search for meaning. Fast forward to the 20th century, and you'll find celestial cartography playing a central role in one of the most iconic franchises in pop culture, Star Trek. The Starship Enterprise's mission to explore strange new worlds is built on the foundation of star maps. The show's creators didn't just imagine a future of interstellar travel, they grounded it in a sense of realism, using known stars and constellations as the backdrop for their stories. The star charts in Star Trek aren't just props, they're tools for exploration, reflecting humanity's enduring fascination with the cosmos and our desire to chart the unknown. The series even introduced the concept of the star date, a fictional timekeeping system that adds a layer of authenticity to its vision of the future. Literature and pop culture have also used celestial cartography to explore themes of fate and destiny. In J.R.R. Tolkien's The Lord of the Rings, the stars are a recurring motif, symbolizing hope and guidance in dark times. Characters like Aragorn and Frodo look to the heavens for reassurance, finding solace in the constancy of the stars. Similarly, in Harry Potter, the constellation of Orion plays a subtle but significant role, with characters named after stars and constellations hinting at their roles in the story. These examples show how star maps and celestial imagery can add depth and symbolism to storytelling, connecting characters and readers to something larger than themselves. But it's not just in epic tales that celestial cartography finds its place. Even in contemporary works, the stars continue to inspire. Consider Andy Weir's The Martian, where the protagonist, Mark Watney, uses his knowledge of celestial mechanics to navigate his way back to Earth. The novel's meticulous attention to the science of space travel highlights how real-world star maps and orbital dynamics can drive a story forward. It's a reminder that the stars aren't just poetic, they're practical, offering a way to ground even the most fantastical narratives in reality. What's fascinating about these examples is how they reflect the dual nature of celestial cartography. It's both a science and an art. In literature and pop culture, star maps serve as bridges between the tangible and the intangible, the real and the imagined. They allow us to explore not just the universe, but also the human experience, our dreams, fears, and aspirations. Whether it's Dante's spiritual journey, the Enterprise's voyages, or Watney's fight for survival, the stars remind us that storytelling is, at its core, about connection. They invite us to look up, to wonder, and to imagine what lies beyond the limits of our world. By blending the precision of celestial cartography with the creativity of storytelling, these works show us that the night sky is more than just a scientific frontier. It's a canvas for the human imagination. And as long as we continue to look to the stars, they'll keep inspiring stories that challenge, entertain, and illuminate the mysteries of the cosmos and ourselves. Despite centuries of mapping the stars, the universe still holds countless secrets that defy our understanding. Even with the most advanced telescopes and cutting-edge technology, we've only scratched the surface of what's out there. Dark energy, for instance, remains one of the most perplexing mysteries in modern science. This invisible force, which makes up about 68% of the universe, is causing the cosmos to expand at an accelerating rate. But what is it? Where does it come from? And how does it work? These are questions that keep astronomers awake at night, driving them to push the boundaries of what we know. Then there's the enigma of black holes, those cosmic vacuums so dense that not even light can escape their grasp. While we've made incredible strides in observing these mysterious objects, thanks to breakthroughs like the first ever image of a black hole captured in 2019, they still raise more questions than answers. What happens inside a black hole? Do they lead to other dimensions, or are they the ultimate dead end? And how do they shape the galaxies around them? Each discovery about black holes seems to open up a new frontier of inquiry, reminding us just how much we have yet to learn. But perhaps the biggest mystery of all is the origin of the universe itself. The Big Bang Theory gives us a framework for understanding how the cosmos began, but it doesn't answer everything. What triggered the Big Bang? What existed before it? And why does the universe have the precise properties that allow galaxies, stars, and even life to exist? These are the kinds of questions that propel astronomers to peer deeper into the cosmos, searching for clues in the faint echoes of the universe's earliest moments. Projects like the James Webb Space Telescope are designed to explore these very questions, offering a glimpse into the universe's infancy and shedding light on its ultimate origins. What's fascinating about these mysteries is how interconnected they are. Dark energy, black holes, and the origins of the cosmos aren't separate puzzles. They are pieces of a larger picture, each one influencing our understanding of the others. Mapping these unknowns isn't just about filling in gaps in our knowledge. It's about uncovering the fundamental truths that govern the universe. And while the challenges are immense, so too are the opportunities for discovery. Every observation, every experiment, and every new piece of data brings us one step closer to solving these cosmic riddles. At the heart of this quest is a simple, profound truth: the universe is full of surprises. Just when we think we've figured something out, it reveals a new layer of complexity. This is what makes celestial cartography so exhilarating. It's not just about mapping what we know, but venturing into the unknown. It's about embracing the mystery, asking bold questions, and daring to imagine what lies beyond the limits of our current understanding. And as we continue to explore, one thing is certain: the cosmos will always have more stories to tell, more secrets to share, and more wonders to reveal. As we gaze up at the stars, it's easy to think of celestial cartography as a purely cosmic endeavor, an exploration of distant galaxies, nebulae, and exoplanets. But what if I told you that mapping the heavens can also help us better understand our own planet, particularly when it comes to one of the most pressing issues of our time, climate change? It might seem like a stretch at first, but the connections between celestial cartography and Earth's climate are both profound and surprising. By studying the stars and the conditions of other planets, astronomers are uncovering insights that could shape how we address environmental challenges here on Earth. One of the most fascinating ways celestial cartography intersects with climate science is through the study of exoplanets, planets orbiting stars beyond our solar system. Over the past few decades, astronomers have discovered thousands of these worlds, ranging from scorching gas giants to icy, rocky planets. But what's truly remarkable is how these discoveries are helping us understand the delicate balance that makes a planet habitable. Take, for example, the concept of the Goldilocks zone, the region around a star where temperatures are just right for liquid water to exist. By mapping exoplanets in these zones, scientists can identify which factors contribute to stable climates and which lead to extreme conditions. These findings aren't just academic, they offer valuable lessons for Earth, where maintaining a stable climate is essential for life as we know it. Another key area where celestial cartography informs climate science is through the study of stellar activity. Stars, including our own sun, go through cycles of activity that can influence the climates of the planets orbiting them. By mapping these cycles and their effects on planetary atmospheres, astronomers can better understand how solar flares, sunspots, and other phenomena impact climate systems. This research has direct implications for Earth, where solar activity plays a role in everything from weather patterns to long-term climate trends. By studying how other stars and their planets interact, we gain a broader perspective on the forces that shape planetary climates, including our own. But it's not just about other planets. Celestial cartography also helps us study Earth's climate from a cosmic vantage point. Satellites and space telescopes, originally designed to map distant stars and galaxies, have become invaluable tools for monitoring our planet. Instruments like NASA Terra and Aqua satellites use advanced sensors to track everything from atmospheric composition to sea surface temperatures. These observations provide critical data for climate models, helping scientists predict future changes and develop strategies to mitigate their impact. In a way, celestial cartography has come full circle, using the tools of space exploration to protect the very planet from which we launch those missions. Perhaps the most thought-provoking connection between celestial cartography and climate change lies in the concept of planetary resilience. By studying the atmospheres of other planets, scientists can see what happens when climate systems go awry. Venus, for instance, offers a cautionary tale. Once thought to be Earth's twin, Venus now has a runaway greenhouse effect, with surface temperatures hot enough to melt lead. By mapping Venus's atmosphere and comparing it to Earth's, researchers can better understand the processes that drive climate change and identify potential tipping points we need to avoid. These cosmic comparisons remind us that Earth's climate is not an isolated system, it's part of a larger planetary ecosystem, shaped by forces that extend far beyond our atmosphere. What makes this intersection of celestial cartography and climate science so powerful is its ability to shift our perspective. When we look at Earth from space, we see a fragile, blue oasis, a single planet teeming with life in a vast, seemingly indifferent universe. This cosmic view underscores the urgency of addressing climate change, not just for our own survival, but as part of a broader understanding of planetary stewardship. By mapping the stars, we're not just exploring the cosmos, we're learning how to protect our own small corner of it. In the end, celestial cartography is more than a tool for discovery. It's a lens through which we can better understand ourselves and our place in the universe. Whether it's through the study of exoplanets, stellar activity, or the atmospheres of neighboring worlds, the stars have much to teach us about the challenges we face here on Earth. And as we continue to map the cosmos, we're not just charting distant galaxies, we're uncovering insights that could help us navigate the future of our own planet. The night sky, it turns out, is not just a map of the universe, it's a guide for preserving the world we call home. As we continue to map the stars and explore the cosmos, there's an urgent question we must confront. Will future generations even be able to see the night sky as we do? Light pollution and space debris are two growing threats that could obscure our view of the stars, making it harder to connect with the universe in the way humans have for millennia. The glow of artificial lights from cities and towns has already washed out the stars for millions of people, while the growing cloud of space debris orbiting Earth poses risks to both astronomy and space exploration. Protecting our celestial heritage isn't just about preserving a beautiful view, it's about safeguarding the ability to explore, dream, and understand our place in the cosmos. Light pollution is one of the most immediate challenges. For many people living in urban areas, the night sky is no longer a tapestry of stars, but a hazy, orange glow. This artificial brightness doesn't just rob us of the beauty of the stars, it disrupts ecosystems, affects human health, and hinders scientific research. Telescopes, both on the ground and in space, rely on dark skies to capture the faint light of distant galaxies and nebulae. When that light is drowned out by streetlights and billboards, it becomes harder to make groundbreaking discoveries. Organizations like the International Dark Sky Association are working to combat this issue, advocating for smarter lighting practices and creating designated dark sky preserves where the stars can still shine brightly. These efforts remind us that the night sky is a shared resource, one that deserves protection for both its scientific and cultural value. But light pollution isn't the only threat to our view of the stars. Space debris, the remnants of old satellites, rocket stages, and other human-made objects has become a growing concern. With thousands of defunct satellites and millions of smaller pieces of debris orbiting Earth, the risk of collisions is increasing. Not only does this debris pose a danger to active satellites and spacecraft, but it also creates a reflective haze that can interfere with astronomical observations. Imagine trying to study the faint light of a distant galaxy while a swarm of shiny debris streaks across your field of view. It's a problem that requires global cooperation, from designing satellites that minimize debris to developing technologies to clean up what's already there. Preserving the night sky isn't just about what we do on Earth, it's about how we manage our presence in space. The importance of dark skies goes beyond science. It's deeply tied to our cultural and emotional connection to the stars. For countless generations, the night sky has been a source of wonder, inspiration, and storytelling. It's where we've mapped our myths, navigated our journeys, and dreamed of what lies beyond. Losing that connection would mean losing a part of what makes us human. Efforts to preserve dark skies aren't just about protecting the stars. They're about preserving a legacy for future generations. Imagine a child looking up at the Milky Way for the first time, feeling that same sense of awe that has inspired explorers, scientists, and dreamers throughout history. That experience is worth fighting for. Fortunately, there's hope. Around the world, communities are taking steps to reduce light pollution and protect dark skies. From small towns adopting dark sky ordinances to entire regions being designated as dark sky reserves, these efforts show that change is possible. And in space, initiatives like the European Space Agency's Clean Space Program are working to tackle the problem of space debris, ensuring that the stars remain visible for centuries to come. These actions remind us that protecting the night sky is a collective responsibility, one that requires collaboration across borders, disciplines, and generations. The stars have guided us for as long as we've looked up. They've shaped our cultures, driven our curiosity, and inspired our greatest achievements. Preserving the night sky isn't just about maintaining a view, it's about ensuring that future generations can continue to explore, dream, and connect with the cosmos. It's a reminder that the universe is a shared treasure, one that belongs to all of us, and one that we must protect for those who will come after us. After all, the stars aren't just points of light, they're a bridge between the past, the present, and the future, a reminder of our place in the vast expanse of space and time. The stars have always been a source of wonder, but they're also an incredible tool for learning. Celestial cartography isn't just about charting the heavens, it's about opening minds, sparking curiosity, and inspiring the next generation of explorers, scientists, and dreamers. In classrooms around the world, star maps are becoming a gateway to the cosmos, helping students of all ages connect with the universe in ways that are both educational and deeply personal. From hands-on activities to cutting-edge technology, celestial cartography is transforming how we teach and learn about the stars. One of the most exciting ways star mapping is used in education is through planetarium programs. These immersive experiences allow students to step inside a dome-shaped theater and gaze up at a simulated night sky, complete with constellations, planets, and even distant galaxies. It's not just about seeing the stars, it's about understanding their stories. Planetarium educators use star maps to guide students through the myths and science behind the constellations, showing how cultures around the world have interpreted the same patterns of light. This blend of storytelling and science makes astronomy accessible and engaging, turning the night sky into a classroom without walls. But it's not just about looking up, it's about getting hands-on. Many schools and outreach programs are incorporating celestial cartography into physical activities, like creating their own star charts. Students might start by identifying constellations in the night sky, then transfer those patterns onto paper, learning about scale, distance, and perspective along the way. These projects aren't just fun, they're a way to build critical thinking and problem-solving skills. By mapping the stars themselves, students become active participants in their learning, transforming abstract concepts into something tangible and real. Technology is also playing a huge role in bringing celestial cartography into the classroom. Apps and software like Stellarium and Sky Safari allow students to explore the night sky in real time, even in the middle of the day. These tools aren't just digital star maps, they're interactive learning platforms. Students can zoom in on planets, track the movement of the moon, or even simulate what the sky looked like on the day they were born. It's a way to make astronomy personal, showing students that the stars aren't just distant objects, they're part of their story too. Outreach programs are another key way celestial cartography is inspiring young minds. Organizations like NASA and local astronomy clubs often host star parties, where students and their families can look through telescopes, learn about constellations, and even take home their own star maps. These events are more than just fun, they're a way to break down barriers to science education, making astronomy accessible to everyone, regardless of background or resources. For many students, a star party might be their first chance to see Saturn's rings or the craters of the moon up close, sparking a lifelong passion for the stars. What's truly remarkable about using celestial cartography in education is how it bridges the gap between science and imagination. The stars aren't just points of light, they're a canvas for creativity, a way to explore big questions about our place in the universe. When students learn to map the stars, they're not just memorizing facts, they're engaging with the cosmos in a way that's both intellectual and emotional. It's a reminder that science isn't just about answers, it's about curiosity, wonder, and the thrill of discovery. By bringing celestial cartography into the classroom, we're not just teaching students about the stars, we're giving them the tools to explore, question, and dream. Whether it's through a planetarium show, a hands-on project, or a night under the stars, these experiences have the power to shape how young people see the world and their place in it. The night sky is more than a map, it's a mirror reflecting our curiosity, our creativity, and our endless desire to understand the universe. And as we inspire the next generation of stargazers, we're ensuring that the stars will continue to guide us, not just in the sky, but in the hearts and minds of those who look up. As we chart the stars and uncover the secrets of the cosmos, a question emerges that goes beyond science and technology. Who owns the universe? It's a question that might sound like something out of a science fiction novel, but as humanity's reach extends farther into space, it's becoming a very real ethical dilemma. From mining asteroids for precious metals to claiming territory on other planets, the ability to map and explore the heavens brings with it a host of complex issues about ownership, access, and responsibility. This isn't just about who gets to plant a flag on Mars. It's about ensuring that the stars remain a shared resource, open to all and protected for future generations. One of the most pressing ethical concerns is the commercialization of space. Private companies are already eyeing celestial bodies for their resources, from the water ice on the moon to the rare metals found in asteroids. While this could lead to incredible advancements and economic opportunities, it also raises questions about fairness and equity. Should a single corporation or nation have the right to exploit a resource that belongs to no one and everyone? The Outer Space Treaty of 1967, signed by over 100 countries, declares that space is the province of all mankind. But as technology advances and the stakes grow higher, these principles are being tested. How do we balance innovation with the need to protect the cosmos as a global commons? Another layer of complexity comes from the issue of access. As celestial cartography becomes more advanced, the tools and data needed to explore space are often concentrated in the hands of a few wealthy nations or organizations. This creates a disparity where only a select group has the ability to study and benefit from the universe's resources. Efforts like the Square Kilometre Array, a global collaboration to build the world's largest radio telescope, aim to democratize access to space exploration. But there's still much work to be done to ensure that all nations, regardless of their economic status, have a seat at the table. After all, the stars don't belong to any one country, they belong to humanity as a whole. Then there's the question of environmental responsibility. Just as we've learned the hard way on Earth, exploiting natural resources without considering the consequences can lead to irreversible damage. In space, the stakes are even higher. Mining operations on the Moon or Mars could disrupt delicate ecosystems or create entirely new ones. Even something as seemingly harmless as launching satellites into orbit contributes to the growing problem of space debris, which threatens both current and future missions. Responsible celestial cartography means not just mapping the stars, but doing so in a way that minimizes harm and preserves the integrity of the cosmos for generations to come. At its core, the ethics of celestial cartography is about more than just laws and regulations. It's about values. It's about asking what kind of future we want to create as we venture into the stars. Do we want a future where space is a battleground for resources, or one where it's a shared frontier for exploration and discovery? The choices we make today will shape the legacy we leave behind, not just for ourselves, but for all of humanity. By approaching celestial cartography with a sense of responsibility and respect, we can ensure that the stars remain a source of wonder, inspiration, and unity, not division. The universe is vast, but our connection to it is profound. Let's make sure we honor that connection as we continue to explore the cosmos. When we map the stars, we're not just plotting points of light, we're searching for signs of life. The field of astrobiology takes celestial cartography to a whole new level, blending the precision of star mapping with the curiosity of biology to explore one of humanity's most profound questions: are we alone in the universe? This isn't just about finding planets, it's about identifying the conditions that could support life, from the tiniest microbes to intelligent civilizations. By combining the tools of astronomy with the principles of biology, astrobiologists are turning the night sky into a roadmap for discovering life beyond Earth. At the heart of this search is the concept of habitability. Not all planets are created equal when it comes to supporting life. Some are too hot, others too cold, and many lack the essential ingredients, like liquid water and a stable atmosphere, that make life as we know it possible. Celestial cartography plays a crucial role here, helping scientists identify planets in the Goldilocks zone, where conditions are just right for liquid water to exist. But habitability isn't just about location, it's also about chemistry. By analyzing the atmospheres of distant planets using techniques like spectroscopy, astronomers can detect gases like oxygen, methane, and carbon dioxide chemical signatures that might hint at biological activity. These observations, combined with detailed star maps, allow us to zero in on the most promising candidates for further study. One of the most exciting developments in astrobiology is the discovery of exoplanets, planets orbiting stars beyond our solar system. Since the first exoplanet was confirmed in the early 1990s, thousands more have been found, ranging from rocky worlds similar to Earth to gas giants unlike anything in our solar system. Each discovery adds a new piece to the puzzle of life in the universe. For example, the TRAPPIST-1 system, located about 40 light-years away, has 7 Earth-sized planets, 3 of which are in the habitable zone. By mapping these planets and studying their atmospheres, scientists are uncovering clues about their potential to host life. It's a process that requires both the precision of celestial cartography and the creativity of astrobiology, blending data with imagination to explore what might be out there. But what exactly are we looking for? Life on other planets might not look anything like life on Earth. Astrobiologists are exploring a wide range of possibilities, from extremophiles, organisms that thrive in extreme environments, to entirely new forms of life based on different chemistries. For example, some scientists speculate that life could exist in the subsurface oceans of icy moons like Europa or Enceladus, where liquid water is shielded from the cold vacuum of space. Others are investigating the potential for life in the clouds of Venus, where temperatures and pressures are more Earth-like than on the planet's scorching surface. These possibilities stretch our understanding of what life can be and challenge us to think beyond the boundaries of our own planet. The search for extraterrestrial life isn't just a scientific endeavor, it's a deeply human one. It's about exploring the unknown, asking big questions, and imagining what might be out there. Celestial cartography gives us the tools to navigate this vast frontier, while astrobiology provides the framework for understanding it. Together, they form a partnership that's as much about discovery as it is about inspiration. By mapping the stars and searching for life, we're not just exploring the universe, we're exploring ourselves, our place in the cosmos, and the possibilities that lie beyond the horizon. And in doing so, we're keeping alive that timeless sense of wonder that has always drawn us to the stars. Imagine stepping into the shoes of an astronaut, floating through the vast emptiness of space, or standing on the surface of a distant planet, watching alien suns rise over a rocky horizon. Thanks to virtual reality, this once distant dream is now a tangible experience. VR technology is revolutionizing the way we explore the cosmos, transforming celestial cartography from a flat, two-dimensional endeavor into an immersive, interactive journey. With VR, the universe isn't just something we observe, it's something we can step inside, touch, and explore in ways that were once the stuff of science fiction. One of the most exciting applications of VR in celestial cartography is its ability to bring distant worlds to life. Imagine donning a VR headset and finding yourself on the surface of Mars, surrounded by the planet's iconic red dunes and towering volcanoes. You could walk through the Valles Marineris, a canyon system so vast it makes the Grand Canyon look like a mere scratch, or watch as a dust storm rolls across the horizon. These experiences aren't just visually stunning, they're deeply educational, offering a visceral understanding of planetary geology and the challenges of space exploration. By making the cosmos tangible, VR bridges the gap between abstract concepts and real-world understanding, turning complex ideas into something you can almost reach out and touch. But VR isn't just about visiting familiar places like Mars or the Moon. It's also a portal to the farthest reaches of the universe. With a few clicks, you could find yourself orbiting a black hole, watching as its immense gravity bends light into a glowing ring, or flying through the Orion Nebula, where newborn stars ignite in clouds of gas and dust. These experiences aren't just visually breathtaking, they're scientifically accurate, built on data from telescopes and space missions. VR allows us to explore the cosmos in a way that's both immersive and grounded in reality, offering a new perspective on the wonders of the universe. For educators, VR is a game changer. Traditional classroom tools like textbooks and slideshows can only go so far in conveying the scale and complexity of the cosmos. But with VR, students can take a virtual field trip to the International Space Station, where they can float in microgravity and peer down at Earth, or explore the intricate structure of a galaxy millions of light years away. These experiences don't just teach facts, they spark curiosity, inspire questions, and make learning an adventure. By turning passive observation into active exploration, VR has the power to ignite a lifelong passion for astronomy in students of all ages. Of course, VR's potential goes beyond education. It's also a tool for discovery. Astronomers and researchers are beginning to use VR to visualize complex data sets, from the distribution of galaxies in the cosmic web to the intricate orbits of exoplanets. By stepping inside these virtual models, scientists can gain new insights into the structure and behavior of the universe, uncovering patterns and relationships that might be invisible in traditional 2D representations. It's a way of seeing the cosmos that's as innovative as it is intuitive, blending cutting-edge technology with the timeless human desire to explore and understand. What makes VR so powerful is its ability to connect us to the cosmos on a deeply personal level. When you're standing on the surface of a distant planet or flying through a galaxy, the universe stops being an abstract concept. It becomes a place you've been, a place you've experienced. This sense of connection is what makes VR more than just a tool. It's a bridge between the human imagination and the vast, mysterious expanse of space. By bringing the stars closer, VR reminds us that the cosmos isn't just something we study, it's something we're a part of, a story we're still writing. As VR technology continues to evolve, its role in celestial cartography will only grow. From education to research to pure exploration, VR is opening up new frontiers in how we see and understand the universe. It's a reminder that the stars aren't just points of light in the sky, they're destinations waiting to be explored. And with VR, we're not just mapping the cosmos, we're stepping into it, one virtual world at a time. When we look up at the night sky, we're not just seeing the stars as they are now, we're catching glimpses of the past. The light from even the closest star, Proxima Centauri, takes over 4 years to reach us, meaning we're seeing it as it was 4 years ago. For more distant objects, like galaxies billions of light years away, we're peering back billions of years into the universe's history. Celestial cartography isn't just about plotting points in space. It's about creating a timeline of the cosmos, a map that reveals not only where things are but also when they existed. This incredible ability to see into the past transforms the night sky into a kind of time machine, one that allows us to witness the universe's evolution firsthand. Think of it this way: every star map is also a history book. The positions of stars, galaxies, and other celestial objects tell us not just about their current locations, but also about the events that shaped them. For example, when we observe the light from a distant galaxy, we're seeing it as it was when the light first began its journey to Earth. If that galaxy is 10 billion light-years away, we're seeing it as it was 10 billion years ago, a time when the universe was still in its infancy. By mapping these ancient galaxies, astronomers can piece together the story of how the universe grew from a hot, dense state after the Big Bang into the vast, complex structure we see today. But how do we turn this light into a timeline? It all comes down to something called redshift. As the universe expands, the light from distant objects stretches, shifting toward the red end of the spectrum. The more distant the object, the greater the redshift, and the further back in time we're looking. By measuring redshift, scientists can determine not just how far away an object is, but also how old the light we're seeing is. This technique has allowed astronomers to create detailed maps of the universe's history, showing how galaxies formed, evolved, and clustered together over billions of years. It's like flipping through a cosmic photo album, with each image capturing a different stage of the universe's development. One of the most remarkable examples of this is the Hubble Deep Field, an image that captured thousands of galaxies in a tiny patch of sky. What makes this image so extraordinary is that it's not just a snapshot of distant galaxies, it's a window into the universe's past. Some of the galaxies in the deep field are so far away that their light has been traveling for over 13 billion years, meaning we're seeing them as they were just a few 100 million years after the Big Bang. These ancient galaxies are smaller, younger, and more chaotic than the ones we see today, offering a glimpse into the universe's early stages of growth. By mapping these distant objects, we're not just exploring space, we're exploring time itself. This ability to map the universe's history has profound implications for our understanding of cosmology. By studying how galaxies have changed over time, astronomers can test theories about the universe's origins, expansion, and ultimate fate. For instance, observations of distant supernova have revealed that the universe is not only expanding but accelerating in its expansion, a discovery that earned the Nobel Prize in Physics in 2011. This acceleration is driven by dark energy, a mysterious force that makes up about 68% of the universe. By mapping the distribution of galaxies and measuring their redshifts, scientists can study how dark energy has influenced the universe's evolution, offering clues about its nature and behavior. What's truly fascinating about this cosmic timeline is how it connects us to the universe's story. The light we see from distant stars and galaxies is a bridge between the past and the present, a reminder that the universe is constantly evolving. When we map the stars, we're not just charting their positions, we're uncovering the history of the cosmos itself. It's a story that began with the Big Bang and continues to unfold with every new observation, every new discovery. And as our tools and techniques continue to improve, we'll be able to see even further back in time, revealing more of the universe's secrets and deepening our understanding of where we came from and where we're going. Artificial intelligence is no longer just the stuff of futuristic dreams. It's here, and it's revolutionizing how we explore the cosmos. In the world of celestial cartography, where the sheer volume of data can be overwhelming, AI has become an indispensable ally. It's like having a tireless assistant that can sift through mountains of information in seconds, spotting patterns and anomalies that might take humans years, or even lifetimes, to uncover. From pinpointing distant exoplanets to mapping the invisible threads of dark matter, AI is reshaping our understanding of the universe, one algorithm at a time. Take the search for exoplanets, for example. With thousands of stars to monitor and countless data points to analyze, astronomers have turned to AI to help identify potential planets. Machine learning algorithms can quickly scan through light curves, graphs that show how a star's brightness changes over time, and flag the subtle dips that indicate a planet passing in front of its star. This isn't just about speed, it's about precision. AI can detect signals that are too faint or too complex for traditional methods, uncovering planets that might otherwise have been missed. In this way, AI isn't just a tool, it's a game changer, opening up new frontiers in the hunt for worlds beyond our solar system. But AI's role doesn't stop at exoplanets. It's also helping us map the invisible. Dark matter, for instance, doesn't emit light or interact with electromagnetic forces, making it incredibly difficult to detect. Yet, its gravitational effects are unmistakable, bending light from distant galaxies in a phenomenon known as gravitational lensing. AI can analyze these distortions, reconstructing the distribution of dark matter across the cosmos. By training algorithms on vast datasets, scientists can create detailed maps of this mysterious substance, revealing the hidden structure of the universe. It's a bit like using a cosmic detective to uncover clues that were once invisible to the naked eye. What makes AI so powerful is its ability to learn and adapt. Unlike traditional software, which follows rigid instructions, AI can improve over time, refining its models as it processes more data. This adaptability is particularly useful in astronomy, where the universe constantly surprises us with new phenomena. For instance, AI has been used to classify galaxies, distinguishing between spiral, elliptical, and irregular shapes with remarkable accuracy. It's even helping astronomers identify rare objects, like quasars and supernovae, that might otherwise be overlooked in the vast sea of celestial data. By automating these tasks, AI frees up researchers to focus on the bigger questions, like what these discoveries mean for our understanding of the cosmos. Yet, AI isn't without its challenges. Training these algorithms requires massive datasets, which can be difficult to compile and manage. There's also the risk of bias. If the data used to train an AI system is incomplete or skewed, its conclusions may be flawed. That's why collaboration between astronomers and computer scientists is so important, ensuring that AI tools are both accurate and reliable. It's a reminder that while AI is powerful, it's not infallible. It's a tool, not a replacement for human curiosity and creativity. What's truly exciting about AI's role in celestial cartography is how it democratizes discovery. Thanks to open-source platforms and collaborative projects, amateur astronomers and citizen scientists can now use AI to analyze data, making meaningful contributions to the field. This accessibility is key to advancing our understanding of the universe, bringing more minds and perspectives to the table. After all, the stars belong to everyone, and AI is helping to ensure that everyone has a chance to explore them. As we look to the future, the possibilities for AI in celestial cartography are virtually limitless. From mapping the cosmic web to predicting the behavior of black holes, AI is poised to unlock new insights into the universe's most enduring mysteries. It's a partnership between human ingenuity and machine intelligence, one that's transforming how we see the cosmos and our place within it. The stars have always inspired us to dream big. With AI, those dreams are closer than ever to becoming reality. As we map the stars, we're not just charting the positions of planets and galaxies, we're also searching for something far more profound, the possibility of life beyond Earth. This quest, known as the Search for Extraterrestrial Intelligence, or SETI, is one of the most fascinating and ambitious endeavors in modern science. At its core, SETI is about answering a question that has captivated humanity for centuries. Are we alone in the universe? And while the search for alien civilizations might sound like the plot of a sci-fi movie, it's grounded in the meticulous work of celestial cartography. By mapping the stars and identifying potentially habitable worlds, astronomers are laying the groundwork for one of the greatest discoveries in history. The first step in this cosmic detective story is finding the right places to look. Not all stars are created equal when it comes to hosting life. Some burn too hot and fast, while others are too dim and cool to sustain liquid water, a key ingredient for life as we know it. Celestial cartography helps narrow the search by identifying stars with planets in the Goldilocks zone, where temperatures are just right for liquid water to exist. But it's not just about location, it's also about stability. A star with frequent solar flares or extreme variability could make life on its planets unlikely. By mapping these factors, astronomers can create a kind of cosmic address book, listing the most promising targets for further study. Once we've identified a potentially habitable planet, the next step is to study its atmosphere. This is where celestial cartography and spectroscopy come together. By analyzing the light that passes through a planet's atmosphere, scientists can detect chemical signatures, gases like oxygen, methane, or even industrial pollutants that might hint at biological activity. For example, the presence of oxygen and methane in the same atmosphere could be a strong indicator of life, as these gases tend to react with each other and disappear unless they're constantly replenished. These observations, combined with detailed star maps, allow us to zero in on planets that might not just host life, but intelligent civilizations capable of shaping their environment. Of course, finding signs of life is one thing, detecting intelligent life is another. This is where SETI more traditional methods come into play. Radio telescopes scan the skies for signals that might indicate the presence of advanced civilizations, from deliberate transmissions to unintentional leaks of radio waves. Celestial cartography plays a crucial role here, too. By mapping the positions of stars and their planets, astronomers can focus their searches on systems that are most likely to harbor intelligent life. It's a bit like tuning a cosmic radio, searching for a signal amidst the static of the universe. But SETI isn't just about listening, it's also about looking. Telescopes like the James Webb Space Telescope are designed to study the atmospheres of distant planets, searching for signs of technology, such as artificial lights or megastructures like Dyson spheres. These hypothetical constructs, designed to harness the energy of a star, would leave a distinct signature that could be detected from Earth. By mapping the light and heat signatures of distant stars, astronomers can search for these telltale signs of advanced civilizations, turning the stars into a kind of cosmic billboard for intelligent life. What makes this search so compelling is its blend of science and imagination. While we don't yet have proof of extraterrestrial intelligence, the possibility is enough to drive us forward. Every new exoplanet discovered, every new star mapped, brings us one step closer to answering one of humanity's oldest questions. And even if we don't find aliens tomorrow, the search itself is a testament to our curiosity, our creativity, and our unyielding desire to explore the unknown. In mapping the stars, we're not just charting the cosmos, we're mapping the future of humanity and the story we might one day share with another civilization among the stars. As we bring this journey through the stars to a close, it's clear that celestial cartography is far more than a scientific pursuit. It's a timeless adventure that bridges the past, present, and future. From the earliest star maps etched into clay tablets by ancient civilizations to the breathtaking 3D models of galaxies created by modern telescopes, this field has continually reshaped how we see the cosmos. It's a story of curiosity, innovation, and the unrelenting human drive to explore the unknown. And while the tools and techniques have evolved, the fundamental question remains the same. What lies beyond the horizon? For centuries, the stars have served as our guides, navigating sailors across uncharted seas, inspiring poets to craft timeless verses, and fueling the dreams of scientists who dared to imagine what lies beyond our world. Today, whether you're an amateur astronomer with a backyard telescope or a professional unlocking the secrets of distant galaxies, the night sky remains a source of endless wonder. It's a reminder that the universe is not just something we study, it's something we're a part of, a vast and intricate tapestry that connects us all. As you step outside and gaze up at the stars, remember that every point of light has a story to tell. Each constellation, each nebula, each distant galaxy is a piece of a puzzle we're still piecing together. And while the cosmos may seem infinite and unknowable, that's precisely what makes it so captivating. Every discovery, no matter how small, brings us closer to understanding our place in the universe. So, whether you're sketching your first star map, exploring the cosmos through a telescope, or simply marveling at the beauty of a clear night sky, know that you're part of a tradition that spans millennia. The stars have always been there to guide us, and they always will be. Keep looking up, keep asking questions, and keep dreaming big. Before we wrap up, don't forget to hit that like button, subscribe to the channel, and share your thoughts in the comments below. What's your favorite constellation? Have you ever spotted a nebula or a distant galaxy? Let's keep the conversation going. Until next time, keep your eyes on the stars and your curiosity alive. The universe is waiting.